Fantastic. Thanks very much, and great talk so far, guys and ladies. And I'm looking forward to building on that as we go into my deck. A little bit about ADLINK first, just in case you haven't heard of us. And I'll just make sure my screen flicks down. There we go. So if you go and search for us, we will come up as a hardware company. But actually, our tagline is leading edge computing. We are traditionally a hardware organization. We provide things from small modules all the way up to industrial PCs, very high powered devices, Intel and NVIDIA partners. We are now moving much more into combined hardware and software. And that's where my role comes within the business. I look at solutions. And you can see here, so we've had some recognition as well as being leading in this space, which is fantastic. To keep us back on track, you just heard a lot of the partners talk about, the presenters talk about the reasons for edge computing. I don't need to go over it. I completely agree with what's being talked about in terms of the reason we need to sense, process, and act at the edge. What I want to talk a little bit about is machine vision. I think that's quite an interesting topic. We've got some use cases that I'll run through in a second. And as you heard earlier, the real task, first of all, is to build your model. You need to gather the images, mark the objects, train and test them. And as before, cloud is a really good place to do that as a platform. But obviously, we're talking about edge computing, and we want to be able to use images and sense, process, and act. And that's the aim behind edge computing, is to create some value from that data that you've collected and trained to do that. And I've seen some fantastic solutions now where you can do the training at the edge using medium to high powered devices. In terms of use cases, I want to talk about this use case in particular. We've got asked to get involved with Smart Pallet. It's about palletization. And in this use case, we're actually trying to increase employee productivity and accuracy of packing, but also reduce theft. And I'm going to show you actually some video which is taken from the camera that's looking down onto the actual pallet. So this is not the operator view, of course, because this is not what the operators want to see. They want to actually get a red or green light as to they've packed correctly the pallet. What we're doing here is we detect the pallets. You've got two alongside each other here. We detect the pallets, and then we're looking down to detect the boxes. So first of all, we need to read barcodes. Is the right box on the right pallet? It's green. If it's not, then it goes red. And you can see on here, we've also highlighted boxes which are red because there is no barcode. So we had to train a model to identify boxes. And the reason that was done is because obviously you then can't guarantee whether this pallet is correctly packed. But also there was, in some circumstances, this was a way that there was shrinkage. There was theft in the system where boxes were being turned over and taken off during the delivery chain. So it was, this is a way of making sure pallets were tracked and photographed. This use case is a smart pack, as we call it. So in this use case, this is for effectively, this is Girl Scout cookies in the US. And this is the way this works is the Girl Scout cookies get delivered into the third-party logistics. They are coming on huge pallets and they get repacked for distribution to customers. And you can see in this use case, we're looking at, this is actual production line. You can see the camera on the right-hand side and the screen at the top. That's reading the barcode off the box. It's sending that data back to the ERP system, working out what should be in the box, and then looking down at the box, another camera, and detecting what cookie boxes are there. And on the left-hand side at the top of the screen, you can see a little light come on, green or red, which indicates whether that box is correctly packed. And this is edge computing with AI in action. The accuracy of this was that traditionally 75 to 80% accuracy on packing, which caused a lot of waste in the system with rescheduling customer orders and complaints. This went up to 99% by implementation of this system on the production lines. And this company will now do all the Girl Scout cookies next year by introducing Edge AI. Okay. And we've heard a lot of the discussion before in terms of devices and cloud access and so on. And one of the things we noticed in our solutions is that certainly in manufacturing logistics, the devices aren't connected to the cloud. They are typically aggregated through a gateway for the security reasons. but also because they don't need to be. We're going to do the processing at the edge. And when that data needs to go to the cloud, you can trigger that through a single device. And that's actually because, you know, IT and OT are owned by different people in organizations. And the IT team, very conscious about security. And so they basically partition the networks. So that's how we see typical deployments on sites where you have to split off. So expecting cloud connectivity for all edge devices in industry is unrealistic. The way that this works is, so you can see also here, we move the data around, and that's one of the key things we do at ADLINK on our devices and other devices, is we move the data around between different types of assets so we can connect different types of things. And I'll explain why we do that in this way. But if we think about everything we put on a device as an app, a container, then it gives that device its purpose. And then it's about where we move the data to create the actual systems that we deploy. I wanted to spend a little bit of time covering the key characteristics of data sharing systems. We've heard a lot so far in the discussions about models and training. We've heard a lot about the hardware and choices of processors. And one of the questions that was raised, quite interesting, was about how do we communicate between devices to make these systems work. One of the key things that we found is when you deploy systems into customers, is that they need the ability to evolve the system. So our data river, which we call it, which is our data bus, is built with the concept of using data centric. So it's not about the topology of your system. It's not about the connections. It's about data. So think of that a bit like newspapers. The newspaper sellers, they print the newspaper, but they don't care. They don't know who buys it, and the buyers don't care where it was printed. And it's the same concept with us when we build systems, is you've got producers of data and consumers of data, and they can be deployed on different pieces of hardware to build a system in the most effective way. And that allows you to upgrade your systems without impacting existing systems. Also key to this type of system when you deploy is the quality of service and latency, as we heard. In the discussion before, in the videos before, we needed to flash that light quick enough so that actually it made the action worthwhile. The person packing the pallet, it needs to flash before they turn around, otherwise it slows the whole process down. So speed is really important, and latency within that network. But also, what happens if that network gets busy? So you need to be able to describe your data in terms of what is its priority. Does it need to be reliable and always delivered, or is it just best effort and delivered if you can, but otherwise I'll take the next piece of data? And also, what's the fault tolerance? These are business critical systems. You don't want to lose your whole system because maybe part of it fails. Maybe you can continue to operate. And so these come up in discussions when we are rolling out. To be honest, my background for the last 20 years has been in military and aerospace systems, building data movement. And the military sorted this out 20 years ago. A battleship, for instance, is a great use case for an edge AI system. And they use this technology to do that. That's what we use in our data bus. And they realized that because things like, which we see in POCs all the time, MQTT, it doesn't scale sometimes to those bigger systems. You need to add more functionality into your applications to deal with some of these prioritization reliability issues when you want to scale out to larger systems. Also, customers don't want to be locked in, so they want to be able to have access to that data from the platform, whether that's the inference results or the raw data, to be able to then build on other systems. That's important for them for a cost structure. And we all know about security. Built in from the start is also something that needs to be done, but it's locked down. In industry, they look at all the attack surfaces, and it's a key one there in crossing the divides. I wanted to look in vision in particular. So as well as being able to distribute lots of different functions across devices, there's a few key things here, and that's been highlighted, I think, before as well. When we build systems, the way we do it in ADLINK is we've got a generic video pipeline, shall we say, our vision pipeline, and connecting to manufacturing equipment as well to take actions. What we do is we're aware that the model builders, they have their own technology they want to integrate. They might want to build it for Intel. They might want to build it for NVIDIA. They might want to build their own particular inference engine. And we allow that to be plugged into our pipeline fairly straightforward. And we also take care of the distribution of the models to all the inference engines at the edge. If you've got one aggregated gateway, you want to pass the model down to that and have it share it to all the different inference streams that are running when you do an upgrade. The people who build the data science models typically don't care about integration and don't really have that skill set. They want to build the model, they want the training data. That's really what they're interested in. So we support that as well to allow you to plug and play. Different hardware choice to match your environments, so that's NVIDIA, Intel, is also possible to match the runtime engines. But also the key thing about video is it's large. In some of the circumstances, you need really accurate video frames. This can be large data, and putting them onto the network can be really painful. So the ability to choose what to put there when you're training, you obviously want to put it all in there to capture it. But once it's in inference mode, the only things you want to put on there maybe the failing frame rates, frame detection where it's not a high enough percentage so that you can retrain. But otherwise, process as quickly as fast as possible on the device, and then transform it into other types of video streams if you want to view it. So that's one thing to take into account is when you're doing that, where is your camera and vision device and how powerful is it? Other things to consider when you're doing rollouts of systems is you have a number of people who are providing the solution parts. It's not all particularly one company. We integrate different parts of software as well, our hardware, other hardware as well. ADLINK doesn't have it all, so we need to work with our partners' hardware sometimes too. You have an AI scientist who, as I say, builds the data model. You have system integrators who go and install and customize the solutions for the particular circumstances. And you have typically a managed service provider, which will look after these devices. These are new devices being put in the field, and they need to be looked after. And you may find that your customer has all of these roles within them. They will build it and they will deploy it, and they've got model builders, or you may find they have none, in which case you need to work with your ecosystem to do that, which is what we also do with ADLINK. What I would say is on the successful installation on the customer side, please be aware you will need to involve HR, and there will be changes to standard operating procedures. So please bear that in mind if you're going to go from a proof of concept to a production rollout, because people are really important in that journey. And also interesting things about different business models. So we've seen when we work with system integrators, traditionally in the past, some of them may have delivered a project and then that was their work done. With AI, they get the ability to go back and now touch up models if they have the AI model building skill. So it also applies to managed service providers. They maybe bring in some AI skills and able to do that too. So new business streams for these organizations. And customers, because of the nature of AI and being able to offer new solutions, one of the ones we did with the packing, for instance, was with a meat producer in the US, and they wanted to offer the flexibility to pack multi-product pallets to deliver to customers, rather than just one part of a certain type of meat, which was what was happening in the industry. So they now were able to provide a more flexible business model to capture a different part of the market. And customers that we've worked with, they want to learn about this, what we do and build in solutions. They want to have confidence. And sometimes they will take that, one of the solutions that we build with them, and they will take it to other people in their federation and create a new little business stream for them with rolling out and providing the role of a system integrator in some circumstances. And the other way that we help these system integrators and solution builders is if they are using our products, then we can help them take it to market, because ADLINK does not have all the solutions or all the variations, and we can help market that back through our channel worldwide. So the way we do that is if we deploy containers, if you build a container which fits in our ecosystem, it can be sold back through. Just finally, we to make this easy and try and help people on their journey with vision, because there's a lot of parts to put together when you're building a solution. At ADLINK, we built Visi AI. It's a small Intel dev kit with the Intel VPU on board, because you do need the AI accelerator to make real use here. It also comes with the software stack. So you can go from receiving the device, plugging a webcam to it, and you can be doing inference with some prepackaged models, standard ones from Intel, to texting when you see people in literally 5 minutes. And the idea there is to get you used to the concept, to use it in demos. And when you're ready for production, you can step up to other devices in the ADLINK catalog that give you the higher processing power and industrial kind of casing to allow you to deploy online. We've got a community, go50.ai, that is specifically aimed at helping to educate as well, so that people can go there and learn. As I say, there's different actors involved, system integrators, AI modelers, and there is certainly lots of skills to be learned in putting solutions together. And I think that is me, Nigel. Does that help out as well too?
Yep, thank you very much. That's great.